Hello everyone. In this video, we will learn about the Gini impurity and weighted Gini to build the decision tree. Gini impurity is same as entropy. It also measures the impurity of the node. If Gini is equal to 0, the Gini impurity is 0, then it is a pure node. And if it is equal to 0.5, it is a impure node. The formula to calculate the Gini impurity is 1 minus summation of probability square, where n is the number of classes and p is the probability of each class. For example, for binary classification, we have the Sn known as the output. So Gini impurity for the binary classification task will be 1 minus probability of S square and probability of no square. Okay. We will solve an example based on this formula. Now let's calculate the Gini impurity for the data set where we have to predict whether the student will pass or fail based on the two features, study hours and attendance. So the Gini impurity, to calculate the Gini impurity of data set, first we will count the total, we will have the total count. Total count is equal to 5. And how many number of yes? 2 yes. So yes is equal to 2. And how many number of no's? 3 no's. So no is equal to 3. Then probability of yes will be 2 by 5. And probability of no will be 3 by 5. Our Gini impurity will be Gini of S is equal to 1 minus probability of S square plus probability of no square. That is 1 minus 2 by 5, 2 by 5 square plus 3 by 5 square. This gives the value as Gini of S is equal to 0.48. So this is the Gini impurity of our data set, the overall Gini impurity we have. Now let's split the data by selecting the individual feature. We have to select a individual features like study hour is greater than or equal to 3, or attendance is greater than or equal to 70%. These are my x1 and x2 in the data, right? I have to calculate the weighted Gini for this feature and weighted Gini for attendance feature. Then I have to compare if weighted Gini of study hours is less than weighted Gini of attendance, then I should choose study hours. I should choose study hours to split the data. This is the logic behind using the Gini impurity. So we have calculated the Gini impurity of our total data set. Now we have to calculate the weighted Gini. For each feature, for feature 1 and feature 2. So what is weighted Gini? Weighted Gini is known as CART algorithm, C-A-R-T, CART algorithm. CART stands for classification and regression trees. For both the classification and regression trees, it will use this logic of weighted Gini, and this is used in skitlearn library. This is used in skitlearn. Skitlearn doesn't use the entropy. Skitlearn will use the cart algorithm to build the decision tree. Algorithm chooses the lowest weighted Gini impurity to split the data. What is the formula for weighted Gini? So weighted Gini formula is number of left child nodes, like number of samples, number of data in the left divided by total number of data into Gini impurity of left child. Number of data points in the right child divided by number of total into multiplied by Gini impurity of right child. So we have to take a feature, we have to split the data and calculate the Gini impurity of the left child, Gini impurity of the right child. That will be the overall Gini impurity of the particular column, a single column. I will consider here the example of study hours greater than or equal to 3 to split the data. So my left child, where my study hours are less than 3, is 2 rows, 1 and 2. Here study hours is 1 and study hours is 2. In both the cases, the student will fail. In both the cases, the student will fail. Let's start making the calculation for left child. Total 2. Okay. Out of those, yes are 0 and no are 2. So the probability of yes is 0 and probability of no is 2 by 2, that is 1. Then the Gini impurity of our left child will be 1 minus 0 square plus 1 square. That will be 0. Gini impurity of left child is 0. This is a pure split, pure node or leaf node. Now we will calculate the Gini impurity of our right child. Where the study hours is greater than or equal to 3, we have 3 records. The study hours are 3, 4 and 5. If you see, we have 1 no and 2 yes. We have 1 no and 2 yes. So we calculate Gini impurity. The total are 3. Yes are 2. No is 1. So probability of yes will be 2 by 3. Probability of no will be 1 by 3. And Gini impurity of right child will be 1 minus 2 by 3 square plus 1 by 3 square. You make the calculations, the Gini impurity of right child is equal to 0.44. The Gini impurity is near to 0.5. It is a impure node. This is a impure split. Impure node. We can split further here. This can be splitted further. So we have calculated the Gini impurity of left child and the Gini impurity of right child. So now we have to calculate the weighted Gini. Weighted Gini of study hours, that is n of left by n of total into Gini impurity of left child, n of right into n divided by n of total into Gini impurity of right child. I will rewrite the formula. N of left child divided by n of total into Gini impurity of left child plus n of right child divided by n of total into Gini impurity of right child. So this is the formula to calculate the weighted Gini. If we substitute the values, we have 2 records in the left child. Total is 5 records in the study hours into Gini impurity of left child is 0 plus we have 3 records in the right child divided by total records, that is 5, into Gini impurity of right child is 0.44. So the Gini impurity of study hours is equal to 0.266. Now we have to calculate the Gini impurity. In the same way, the Gini impurity of the attendance greater than or equal to 70%. I will not make the calculation here. The video will be very long if you make the calculation. Suppose consider if our Gini impurity for attendance greater than or equal to 70% is 0.34. The machine will compare these two values. The machine will compare these two values and select the minimum value. That is Gini of study hours. Gini of study hours is less than Gini of attendance. Then the machine will choose Gini of study hours. The column study hours greater than or equal to 3 has a feature to split the data. And it will start building the decision tree. Okay. And you have to notice one point here. I have randomly chosen study hours greater than 3 and attendance greater than or equal to 70%. This is the feature and this is the threshold which I have chosen. But machine will not make the random selection. It will check the Gini impurity for all the values. I mean all the features with different thresholds. Example, study hours greater than or equal to 2 study hours greater than or equal to 4. It will check with the different features and different threshold. Attendance greater than 50%, attendance greater than or equal to 60%. In this way, it will check with the different features and different threshold values, and different features, and find out the best feature. And I will say the find out the feature and threshold with least Gini impurity. To split the data. In this way, the decision tree is built by using Gini impurity and weighted Gini. That is CART algorithm. So it is important building the decision tree. That's all in this video. In next video, we will see the pruning and post pruning and decision tree regression. Thank you.